Unit 4B, Lesson 2, Rearrange Formulas. In this lesson, we're still going to work with that process of completing the square, but rather than using that process to solve for the x values, we're going to use the process to rewrite a quadratic equation from standard form into vertex form. Many of the steps are going to be similar. There's a few subtle differences in this process though. So the steps for completing the square to write a quadratic equation in vertex form. First step is we still want to make the leading coefficient 1. But now we're not going to divide the whole equation by the value of a to make it 1. We're going to factor that value of a out in front only from our x terms. So we still want a coefficient of 1, a leading coefficient of 1, but we don't want to divide the whole equation. We want to factor that a value out in front. The second step is we're still going to add a b over 2 squared quantity to create that perfect square trinomial. But now we're only going to be working with one side of the equation. So rather than adding that value to both sides of the equation, we're going to work on one side. So we add that value and subtract that value later on that same side of the equation. The third step, once we add that b over 2 squared and have that perfect square trinomial, we're going to factor that trinomial and simplify everything that we can. At that point, we should be able to identify the vertex. Now to the first example, we want to rewrite each quadratic equation in vertex form. So right now we're in standard form, y equals ax squared plus bx plus c. We want to get this into vertex form by completing the square. First thing, we have to make sure we have a leading coefficient of 1, which we do, so the first step is taken care of. Now we're going to add that b over 2 squared quantity and subtract it on the right side of the equation. So working with only my x terms, I add my b over 2 squared quantity. My b value is 6, 6 divided by 2 squared. If I'm working with one side of the equation, if I add that quantity, that expression b over 2 squared, I must subtract it somewhere else in order to keep this equation balanced. So I subtract it at the end of the equation. Now this creates a perfect square trinomial that we can factor down, and we can combine and simplify this new constant at the end. So our perfect square trinomial factors down into x plus 3 quantity squared. 6 over 2, 3 squared is 9, 8 minus 9 gets us negative 1. So our equation, if you recall our vertex form, is y equals x plus 3 quantity squared minus 1. We should be able to identify the vertex. The vertex is the ordered pair hk, which in this case, the h value is going to be a negative 3, and our k value is negative 1. That's where our vertex would occur, the x value of negative 3, y value of negative 1. Now to the second example, which is slightly more difficult, because in this example, we do not have an a value of 1. We have an a value of negative 1, so it's not going to be too difficult to make it a value of 1. Now we can't divide the whole equation by negative 1. We have to factor a negative 1 out of only our x values. So now that we factor that negative out of our x terms, we have x squared minus 4x inside the parentheses. We simply put that negative 1 out in front. Now inside the parentheses, we're going to add the b over 2 squared quantity to create that perfect square trinomial. Now we get to the part that tends to be a little bit confusing. So when we added inside the parentheses this 4 over 2 quantity squared, we have to remember that the distributive property is going to apply. This negative out in front applies to every term inside the parentheses. So when we added 4 over 2 quantity squared, now when we apply that negative, we actually subtracted 4 over 2 quantity squared. So if we subtracted that quantity, later on in the equation, we need to add 4 over 2 quantity squared to keep the equation balanced. So remember the distributive property, we're actually subtracting this quantity. That means we have to add that quantity later on. Now the process is the same. We're going to factor this down and simplify to get it into vertex form. So our vertex form is going to be y equals negative And then inside this is going to factor down into x minus 2 quantity squared. And then if we take 4 over 2, which is 2, 2 squared is 4, negative 7 plus 4 gives us negative 3. So our vertex is going to be at the ordered pair 2, negative 3. Recall from the last unit that this negative out in front, the a value being negative, just tells us that our graph is going to open down. So this vertex is going to be a maximum value. And now we get to the last example. We have y equals 2x squared plus 7x minus 9. Similar to the last problem, we need to get our a value to be 1, so we're going to factor a 2 out of our first two x terms. Once we take that 2 out in front, inside the parentheses we're left with x squared plus 7 halves x minus 9. Now we're going to go through and complete the square, add b over 2 squared, and subtract that quantity later on. So our b value is 7 over 2. Talked about this in the first lesson. When you have a b value that's a fraction and you're dividing that by 2, you're just going to multiply that by 1/2. So if you take 7 halves times 1/2, our b over 2 squared is going to be 7 over 4 quantity squared. Again, we applied the distributive property. This 2 applies to every term inside the parentheses. So we actually added a value of 2 times 7 over 4 quantity squared, which means we need to subtract 2 times 7 over 4 quantity squared at the end of the equation. Now we should be able to factor this perfect square trinomial, and we need to simplify to get our constant term. Factoring down this perfect square trinomial, you get y equals 2 times the quantity of x plus 7/4 squared. And then to get our constant, you have to make sure to apply PEMDAS correctly. You need to do exponents before multiplication. 7 squared is 49, divided by 4 squared is 16. Then you multiply the 2 through. Then you get a common denominator. Once you have that, you get negative 72 over 8 minus 49 over 8. Which simplifies to negative 121 over 8. And that means the vertex is going to be at the ordered pair negative 7/4, negative 121 over 8. So rewriting the quadratic equation in vertex form by using completing the square, factor out the a value to get a leading coefficient of 1. Then you're going to add the b over 2 squared quantity, which means you're going to subtract it later on. Unless you have a negative out in front, then you're actually going to add that quantity later on, factor your trinomial, and simplify your constant, then identify the vertex.